I want to welcome you all to our third annual Summit on Decentralization and AI. My name is Jocelyn Weber-Phipps, and I'm the Deputy Director for the Berkeley Center for Responsible Decentralized Intelligence. What I want to do now is welcome to the stage the CEO and founder of Sahara AI, Sean Wren, who's also an associate professor at USC. So please join me in welcoming Sean.
Thanks, everyone. I'm Sean. I'm the co-founder and CEO of Sahara AI, and also a professor at Computer Science Department at USC. Today, I want to share with every one of you some of the learnings and sort of the insights that we actually gained in the past few years while working at the intersection of AI and Web3. And I think all of us, like maybe many of us, have been thinking about what is actually the convergence points between AI and Web3. And we have a lot of the hypotheses at day one when we start this journey together. But I think in the past 2 years, lots of hypotheses has been validated to be wrong or to be valid. And we want to share some of the findings that we have. Still, I want to just lay a little bit context, right? Everyone here must agree that AI is already one of the most transformative and one of the most mainstream technologies since the internet, where not only the market size has been evolved and come into a huge sort of a gigantic size, but also on both enterprise, the business, as well as the consumer markets been widely sort of widespreading and sort of received. And I think the problem that we as Sahara AI and many of you also been talking about as one of the pain points of AI is it's not very open and collaborative as we thought, especially in terms of the monetization perspective, right? Even though we have a lot of open science infrastructure like Hugging Face GitHub that allows people to really build on each other's success, but there's no clear path for these open contributors to continuously to monetize themselves. So the value and control is not really widely distributed. So I think there's very interesting sort of features and components of AI and crypto or Web3. AI been introducing a lot of new digital primitives such as data sets, models, agents that carries real world value, while Web3 offers a lot of interesting tools for transparent ownership, like an open ledger for composability and for trustless collaboration. To us, there's this new opportunity that we've been really exploring the past 2 years to find ways to build AI future as an autonomous system that not only have continuously better intelligence or model capabilities or agent capability, but also there's a new transformative way to govern and monetize through the AI community themselves. So all of these, at the time when we started Sahara AI, tells us that there's no really existing infrastructure layer for achieving this open collaborative governance and monetization on the AI assets. And to really realize the promise of this AI and crypto convergence, we not only need better theoretical alignments, but also usable infrastructure. That means a lot of things, right? Mostly things like protocols for helping revenue sharing, attributions, tracing contributions. We also need, on top of that, protocols, an actual platform that can allow one-stop shop type of end-to-end developments of these AI assets. And we also need applications that really become the gateway for attracting and routing usage and tractions into these platforms, and therefore the protocols being used. All of these elements, if you only build on one or two of them, is not able to really close the loop. And that's the biggest lesson learned that we have in the past 2 years. So Sahara AI, we're still trying very hard in this route to close the loop. We're trying to meet the needs that not as just building a single app, but really creating an ecosystem foundation where open participation, verifiable contribution, and fair monetizations can be achieved in this ecosystem. So I want to just give you a simple view of the problem that we are solving, right? Imagine you have been spending months curating a high quality data set or training a useful AI models that proven to be really useful as received by the open source community. Today, once you just share the recipe of those models, or you actually upload those data sets into some GitHub or other open platform, you lose control over how it's been used and it's been further built on top, and you receive no compensation when someone built a $1 million, say, revenue AI application on top of yours. I think that's a problem many of the researchers talking about today. They are like super talented people, but the best way for them to monetize themselves is still to work for the biggest companies in the AI industry and trying to be part of their economics, right? So really, we think that facing this problem, the decentralized AI should achieve the economic roles such as fair revenue. Every contributor get paid automatically. That's a very important part based on their impact. And this is not happening today, as for especially the data contributors and the model developers. And verifiable attribution, right? The contribution trace should be immutable on chain and proof of who builds what. And composable licensing, meaning that the usage rights should be carried along with the access, such as data sets and models, and it's programmable. So this is sort of the key, I would say, successful pieces that we were trying to build, not just by ourselves, but with many of you here. And why this matters, right? I think we just break this down to different target audiences. For enterprise and data providers, like I said, they lose control immediately once the data set got uploaded into some open marketplace, and the royalty is not being traced properly. So a potential solution towards that is thinking about, can we tokenize those access, license them on-chain, and allows these owners to earn the residuals recursively and autonomously through smart contract. For AI developers and people who fine-tune these models, it's hard for them to monetize the open source contribution, right? Can we solve this problem with some sort of contribution tokens and staking pool that allows them to yield along their contribution? And for Web3 builders, it's still a very tough, technically speaking, for them to build a lot of their tools into the current AI infrastructure and platform because there's lack of AI native economic primitives over there. All right. So and I want to just concretize this whole concept with two real-world user flow, right? Let's say today, if I tell you that once you build a data set, you can register them and monetize them, what that would look like, right? Step one, let's say Sarah uploads the metadata of their data sets and can receive an asset owner NFT token with a token bonded account. And now she can set licensing and usage terms with that data set. Say, if people using it for research, the research license would be like $100 per access, which break down into different API calls. And if it's for commercial license, it's like 10,000. And this will be also set with the royalty terms, such as this amount of incomes into the data sets will be break down into 60% of herself, 20% of the team, and 20% of the collaborators in the industry, for example, the hospital. And now sales come into the data sets, people pay for the licensing access. This is not like in the typical way of like you download the data sets. It's actually like you can do a retrieval augmented generations by just calling APIs over a data set, so you don't have to expose the entire data set. And there will be API call of the data sets into queries into the data sets, and there will be revenue flow into the so-called vault of the data set. And that vault will be sit on a smart contract and autonomously split the revenues. Every time there's a certain amount of balance on the vault, it will be split and send it to the upstream contributors. And further, if the data sets we use in any of the models, and if the models further make revenue, those revenue can also be split and given into the data sets and put into the vault. So it's a recursive and continuous and autonomous revenue sharing experiences now being able to set up for data set builders or data set contributors. For model developments, there will be some sort of like a similar kind of experiences, right? Say Alex and the team registered model receiving an ownership NFT. And now this model will be further iterated into the version 2 by someone fine-tuning the model using their own recipe, someone providing safety filters such as a bunch of post-training data sets that helps with the safety red teaming. And then another person add additional data to help the model to perform better. All of them become the stakeholder, and now once the data set and all these contributions come in to iterate the model from version 1 to version 2, the model start making new revenue streams, and those revenues will autonomously split into all of the contributors into this model. And that's like an ongoing reward that continuously happens down the road, right? So if I summarize whatever that just happens in these two user flow that involves all sort of interesting interactions between the assets and the contributors, we can summarize this into 4 key questions around ownerships about the AI assets. Number 1, who owns the assets, right? Is there like a sovereignty and governance rights along with this owner? Number 2, who contribute to the process of improving these assets or enriching these assets? There should be an attribution sits on chain and verifiable attribution trace that happens. And who can use it? This is all about programmable usage rights that also sits on chain. And then is it legitimate, right? Everything can be verified, like are you actually accessing the right model that claimed to be owned by certain people and contributed by certain people? How do you make sure everything you use is appropriate? And I think these 4 questions are being answered by different technical components and approach that's been developed by us and many of you here in the past. I want to just highlight 2 key concepts. One is this token bonded accounts, right? This giving access their own wallet. This concept is simply put like, if the access is basically seen as a wallet account, then it can receive payment directly, it can sign contracts and issue license, it can be paid out royalty to the contributors, and most importantly, when you transfer the ownership of this access from one person to the other person, the control of the access also got transferred. So that's achieved by this token bonded account concept, TBA. And then the second key concepts many of us are also building here is the licensing system that is programmable about usage rights of these AI assets, right? You can say this is a commercial use versus non-commercial use. What is the derivative? How the derivatives are allowed, right? Can other people build on top of you and commercialize themselves? What is the time limits? What is the geographic restrictions? Many other custom terms. So Sahara AI basically right now is in the stage of building all these infra components that achieve some of the concepts that I talk about at the infrastructure layer that sits at the very bottom. There's AI execution protocols, there's a blockchain accept protocols, but very importantly, we are not only just building infrastructures with the developers, but we are also trying to go to market with enterprise and consumers by building our flagship applications on the application layer. Notably, we have 3 main flagship application products. Number 1 being the data service platform that's been launched for a year and so, being most actively used with hundreds of users daily active. It actually right now still launching many of the data projects along with other Web3 protocol partners that have this what we call due reward programs where you do your task, you earn your base salary payment, but you also earn potentially tokens of the project who launched the data project, and on top of that, you also earn Sahara tokens as the rewards of good performing. And we also have AI developer platform that is one-stop shop for people to come in to say, hey, I'm gonna grab some data set from my local, I'm gonna grab some base models from whatever allows to be deployed, and I'm gonna build my agents, I'm gonna register agents on chain, and then I can publish this on our third product, which is the AI marketplace. This is like basically a 2-sided market, sits on chain, that allows you to purchase license access to data sets, models, agents, and really close the loop of monetizing your data sets on chain with what I just talked about. I think what we learned so far in the past 2 years and we continue trying to achieve is we must rewrite the relationship between AI companies, their users, the contributors of what the AI companies are building to to really achieve a more equitable and transparent ecosystem for all of us, right? Some of us sitting here are developers, some of us are builders, some of us focusing on even just contributing our domain expertise and expert knowledge in the form of data, but we want to find ways to monetize continuously. And we're very lucky to be backed by the best investors in the space across AI and Web3, and want to highlight that we have been very successful in terms of go-to-market, not only just working with consumers and developers, but also with many of the enterprise clients. Our data service platform been serving over 35 different companies, some of the big names such as Microsoft, Amazon, Character AI. They've been using our data service platform to create data sets for training their best model in their vertical. So now just to wrap up, we think an AI-driven future is inevitable, but an open and equitable one isn't there yet. So let's work on this together to join the collaborative AI economy. Thanks, everyone.
One thing I guess you are trying to solve, though I'm sometimes wondering how much is this like an uphill battle, because like the capital interest, like OpenAI obviously, or any big data consumer, they prefer to deal just with like a one-stop shop solution thing. And also I think a lot of the UGC agreements that many of the platforms have that have this valuable data actually allow them to resell it. So that's like the structural question, and then a bit more local to your context as a startup, since a lot of the technology you are building is very kind of supplier focused and empowering, right? You want people to have ownership and equity, but usually the demand side pays for the builds and like the revenue. How do you kind of bridge that as a company?
That's a great question. So just to repeat the first question, right? Like, I think the first question, some simply put, is asking about the market situation, right? Like, who is gonna be using the data service and where does that come from? I think the answer to that are coming from two aspects, right? One is the market actually is much smaller than it's supposed to be. Many of us here actually have very valuable personal data, but we don't find very efficient way and user smooth way to actually publish and monetize it without like worrying about it's gonna go into black market and people just like do whatever they want, right? So there's no such infrastructure exists. So the market is much smaller than it's supposed to be. And second part is like, even though there's many big enterprise companies like OpenAI, Google, been doing data service in-house, which is totally reasonable, because once you have a very stabilized data needs that you need to process, clean, or collect, you're probably just gonna turn it in-house because that's the most cost-effective way. But we have been seeing lots of emerging ad hoc data needs coming from small, medium business, even large enterprise. Like we're still talking to Amazon every week. Their shopping verticals have a lot of interesting language model problems that they don't have in-house resource or capability to do that efficiently. So this emerging needs, even though not come in a very stable like volume, but it's very big as well. So I think the market is still huge enough for many players to come into play. And then the second question is about, can you remind me the second question?
Basically, how you supply oriented.
Oh yeah.
How do you manage this?
Right. Right. So the revenue sharing, I guess the question to reframe it is like the revenue sharing needs. Eventually, people pay the bill, right? Where does the money come from? That's exactly our lesson learned, right? So if you only build infrastructure, if you only build developer ecosystem, but there's no consumers, buyers of the AI usage, then it's not gonna be a very efficient go-to-market, right? That's why we are keep pushing our products from developer-facing products to more consumer-facing products, right? We start building actual vertical agents on-chain that can perform DeFi Copilot, that can perform Creator Copilot, and then these people, there will be hundreds of thousands of people paying the agent usage, and therefore there will be developer coming in to create better agents, seeing the sort of the market, and therefore you can grow the developer community, right? That there should be a sequence of the go-to-market that we must do here. Yeah, thank you. And I see, yes. I think the question is about how would we smooth out the user frictions for Web3 or crypto users on this platform?
Or should we create our own tokens inside the platform?
Right, right. yeah, whether we need to create our own token for them to use, right? I think that's a very interesting question. I think different projects have different view. For us, we want to be agnostic to the trend, to the ecosystem, right? We don't want to just create everything Sahara exclusive, right? We want to serve developers and users of Sonata, of Base, of other EVM chains, right? So we want to create a user experiences no matter which kind of tokens you're familiar you hold, or stable coins. If you're just like a lay users, you're holding stable coin, you can come to this platform to access and purchase and invest into these AI assets in a pretty smooth way. That's kind of the user experiences we are creating. Yeah. Yes?
Thanks so much for the talk. Do you have a strong take on, I guess, what the total value amount to get an individual human on average in the US to give up their data is? Where the transaction feels, positive for all parties involved?
That's a hard question, but I think
it's a super hard question.
Right. I think this is definitely going up to tens or even hundreds of billions of dollars, kind of a market value for that, right? If you're even thinking about all these data service provider today, their total and ARR add up together is about like $1 billion. If you add up all of the business, scale AI, search AI, everything over the globe, I think their annual revenue is adding up like over $1 billion just a year. But if you're thinking about personal data
at a personal
coming into
level.
that, I think it's at least 10x, maybe 100x, right? But I don't have an accurate number.
But like, what does it take to get a single person to activate? Like, if you wanted all of my health data, is it $1? Is it $10? Is it $100?
Right.
$1,000?
So I think this. I'm gonna wrap it up. Sorry. So I think my stand about data pricing is not to price the data set, just price how the data set generate revenues, right? If this data set connect to an agent and there's millions of users paying $5 per month subscriptions accessing that agent, your data set get that revenue split. So I don't want to give a fixed price for selling your data set. You got sort of a rate, like a revenue shares out of that. Yeah. Thank you.
Thank you so much, Sean. And Sahara AI will be doing a workshop today, so if you want to learn more about Sahara AI, please join that. Next, I'd like to welcome up to the stage the CEO and co-founder of Jensen AI, Ben Fielding.
Hey, folks. As Jocelyn mentioned, I'm Ben, co-founder and CEO of Jensen. Before I move on with the presentation, can I see a show of hands, people who know Jensen or have heard of Jensen before? Okay, 30%-ish. I'll do a bit of an introduction then. Wow, does this move things on? Yes. Cool, so I'll give you a quick background on me, I'll give you a quick background on Jensen, and then I'll talk to you about why, in our opinion, the personal superintelligence revolution will be decentralized. This is a bit of a play on Mark Zuckerberg's recent announcement that Meta are working on personal superintelligence. We at Jensen also believe in the future of kind of personal superintelligence. We think that a lot of people have spoken very deeply about how AI is going to automate everything, it's going to take all of our jobs, et cetera, et cetera. Our opinion is that actually the next wave of AI specifically is going to be the personalization of it to every single one of us as individuals, and it's actually going to change the way that we interact with AI and machine learning. And we'll go into kind of what that looks like. I'll go through a bit of history on AI, I'll go through some predictions about what's required next, and then what we at Jensen are doing to enable this to happen and why it can happen in the open, transparently, kind of owned by us as individuals, and ultimately be kind of sovereign and decentralized. But first, this is a bit of information on me. So background in computer science. I did my PhD in deep learning starting back in 2015 when deep learning specifically was kicking off for computer vision. So this was back when computer vision was done very manually by hand. People would build these complex texture filters and things like that to process images. And then along came deep learning and was proven to actually be effective if you executed it using GPUs with AlexNet, which essentially destroyed all of the benchmark results on the ImageNet large-scale visual recognition challenge. And then I came in and started doing deep learning just after this had happened into a computer vision department that was grappling with the difficulty that a lot of the work of the professors in that department for the past 30 years might have suddenly been rendered useless because you could now do it automatically from first principles from the data itself with deep learning without all of this human input. And now we're very used to that. We're used to going end to end from the data and solving problems without humans having to kind of handcraft these things. But back then, expert systems were how we did things. After my PhD, I also co-founded a startup in data privacy. This forms a lot of my beliefs about what's actually going to happen with AI, because I worked directly on the problem of how consumers interact with businesses and what happens to their data when they do that. And I thought a lot about data marketplaces, the idea that we could monetize our own personal data back then, and I came to some conclusions that are probably different from what a lot of people think now. And I'll talk a little bit about that as we go. Finally, I co-founded Jensen 5 years ago now, and Jensen is a decentralized machine learning infrastructure company. So we've been going for over 5 years. We've raised just over $50 million. We're backed by A16Z in our last round, and we're now just over 40 people in the company. So this is actually out of date. Say 35 people on there. We are growing rapidly. Moving on, a little bit of a kind of taxonomy on machine learning and AI. So what are we talking about? So going back in time, we first applied deep learning in anger, so after it had been theory and actual kind of real sort of production in computer vision. That was where it got real kind of effective results. This was around the ImageNet challenge, like I mentioned, but it quickly moved out of that. Not as quickly as we might think now. It actually took a few years, maybe 2 to 3 years, where computer vision researchers were waiting for this to happen within natural language processing, and it didn't. But eventually we got these autoregressive language models. We got the ability to go from kind of raw data and actually build models that could do natural language processing tasks. But there was a weirdly long period of time where a lot of NLP researchers actually strongly disliked deep learning. They didn't think it was going to be effective, and they got quite frustrated by lots of people bringing deep learning techniques to the NLP conferences. But in the end, it did kind of expand to language. I think now what we think about with deep learning is that it's generally applied as a universal function approximator. We can just use it essentially anywhere. This slide is a little bit historical because now that we have foundation models, we actually don't think too much about each domain. We project everything into a single domain, and we just think about data existing in that domain. And so the kind of message I want to get across here is, in the past, we had to think very deeply about specific pieces of data and sources of data and how we were going to process them and what outcome we wanted. Moving forward with deep learning, we're actually thinking more and more about how we can just move data into parameter space. And so raw data that originates with sensors out in the world, it originates with any actions that we as humans take. That data is valuable in its raw form, but now with deep learning, we actually find it more valuable if we move it into the weights of a model. And once it's in the weights of a model, we can do lots of things with it. So we can project it into other domains. We could take an image of this room, and we could project it into the kind of language domain, and we could generate a description of this room. We could project it into audio, and we could generate audio of this room. We could also ask questions which are answered in these different domains. And what's happened is we've offloaded the construction of the questions themselves and the construction of what we want to do with the data to machines. We've given them the ability to think about this data, and in kind of return, in exchange, what we get as humans is much deeper interactivity with that data. And so this requires thinking about machine learning a little bit more from first principles of just saying that we're taking raw data and we're using some objective function that we construct in some way. I'll talk about what those are a little bit later in the presentation. And then by doing that, we're projecting it into this parameter space where we can do a lot more with it. And so we think about machine learning in that way typically at Jensen. It's a much more kind of first principles way of thinking about things, but it kind of leads on to how we do things further. So a little bit of a kind of history, a little bit of a kind of set of techniques for how we've done that the construction of those projections, so that data in parameter space. And so this will be a very abridged history, and there's a few more slides on that I usually give in a longer presentation. But for now, I'll just talk about the progression from supervised learning. So if we look at back in the day, that computer vision kind of breakthrough I talked about, where we went from these handcrafted texture filters that were trying to classify these images into different classes. So take a bunch of pictures, maybe some of them have cats in them, some of them have dogs in them. You get a human to sit down, look at a lot of images, and say, this one has a cat in, this one has a dog in. Once you've done that, you have a data set which allows you to do supervised learning. And so you've got those kind of binary labels, or those really kind of clear labels that say there's a cat in this image or there's a dog in this image, and you run a model on those images over and over again, and out of the end of it, you get a model which has learned what the human did before. And that's why it's supervised learning, because the human went and did the task first. That's great, it's very effective, but it only scales as far as you can get humans to sit down and label images of cats and dogs. And that's a very expensive thing to do. It goes beyond just the electricity cost and the kind of bandwidth cost of running the model, and it gets into the human world with human costs of getting somebody to sit down and label data. We still do a lot of this. You see like it happening all over the world. You see Scale AI's valuation is almost entirely down to the need for supervised data. But quickly, as we moved into foundation models, we started getting more effective results from semi-supervised learning. And so this combines unsupervised learning, which is the idea that you can take enormous amounts of data and you can point a model at that data and it can learn certain things about the data without a human having to sit down and label anything. Principal example of this is clustering. So if I took loads of images and they had cats and dogs in them, and that was the only real distinction that a human would look at, if I clustered those into two clusters, I would probably find out that they clustered into roughly cats and dogs. It wouldn't be perfect because it hasn't used labeled examples. The machine learning model has just taken those images and just logically split them into two, but typically that logical split probably represents the labels. That's what you would assume. And so semi-supervised learning used this concept to combine with supervised learning, where I could take maybe 10,000 images that a human has labeled cat and dog, and then I could take 100,000 images that nobody has labeled. I cluster those images, and then I use the labels to apply further on more images. And in doing that, I get better results than if I just had the 10,000 images from the start. And so I get to scale further without that human effort required. And so this was great. This got us to scale a little bit wider, but we still hit scaling limits. We still hit bottlenecks on data, bottlenecks on compute, bottlenecks on bandwidth, et cetera. And so fast forwarding across these different techniques, there's many techniques we can use. They fit into supervised, semi-supervised, unsupervised learning. More recently, we've got into verifiable reward scenarios. This is the concept that instead of a human sitting down and labeling a piece of data, a human actually constructs the signal that they want a model to take. And so what do I want to happen when a model looks at this data? I can construct a scenario that outlines what I think is good that the model does and what I think is bad or kind of irrelevant. And then I point the model at that data and I say, just pursue the good things. Like if you find these things in the data, then that's good. And I'll give you a kind of good reward signal. And if you don't, then that's not necessarily good and I won't give you any signal. And giving them a kind of big wide remit like this allows them to discover even deeper things about the data. When I say them, I mean the models themselves, but it's a much weaker signal. And so the main kind of message of this slide, I guess, or what I'm saying here is we've progressed from very strong signals coming from humans in supervised learning to weaker signals with semi-supervised learning to even weaker signals with verifiable reward scenarios. And as we do that, we have to scale the models themselves as we go. We have to scale the execution that happens. We have to scale the computation, the communication between the different pieces of model or the models themselves as we scale the models larger. We have to scale basically everything else to deal with the fact that we are processing weaker signals. We at Jensen think we need to keep scaling this far beyond verifiable reward scenarios. Moving on, this talks a little bit about what we're doing to do that scaling. And so a lot of people will know this. Like I said, this is part of a kind of longer talk I typically give where you would get all that history that I've skipped over here. This is just a kind of flag to people about what's happened in recent years in terms of scaling. And so the large model companies, OpenAI, Anthropic, Meta, DeepMind, et cetera, they would all tell you that what we need to do is scale execution right now. We need bigger data centers, we need more GPUs, We need more power in those data centers, et cetera. And that's true if you're vertically scaling machine learning, i.e. if you just take like supervised learning or semi-supervised learning, you've got a data set, you've got enormous amounts of data, you shove it in a data center, and you do as much processing as you can possibly do. Our view is that the diminishing returns on that make it no longer viable. The hyperscalers are trapped in a loop in doing this. They've already committed the funds, they've already committed to taking that path, and it's very difficult for them to change. But new companies and application developers don't need to commit themselves to that path. And actually, the requirement for scale that comes from the weaker signals that we're going to be processing as we scale machine learning will require us to decentralize. And that's horizontal scale. So going beyond the idea of just vertically scaling, putting more GPUs on top of each other in a single data center, to seeking the MapReduce moment for machine learning. MapReduce, for those who don't know, was the kind of breakthrough from Google where they moved from vertically scaling their search infrastructure to suddenly, hey, we can parallelize the operations that are happening in this data center. And so instead of doing 1,000 operations, or now we can do 10,000 operations a second or whatever, we actually just split all those operations across many different horizontal devices, horizontal data centers across the world, and we can do them all in parallel instead of doing them one after the other, but faster. The same is true of machine learning right now. We can parallelize much better than we currently do. We just haven't really discovered the best technique to do it yet, and many teams are focused on doing this. The hyperscalers themselves are focused on this, but they're focused on getting the best out of their data centers. Our view is that we can go wider, and instead of saying, can we get the best out of like 3 data centers, we say, can we get the best out of every single processor on the planet? By moving machine learning closer to the user, personalizing it to the user, and having the execution happen at the user. And I'd encourage people to look up these if you don't already know these techniques. They're just some interesting things that have happened in the space. Moving on, even more recently and going into the future, what is happening with that scaling? So that scaling is going beyond just distributed scaling, where we say, can we make it efficient to go between 2 data centers that one person owns? We say, what if we do an entirely different model architecture? What if we create a model architecture which is inherently decentralized? It has no kind of central coordinator necessarily. It can exist in many pieces. This matches with sparse mixture of expert style models reasonably well. And so this idea that a model itself can actually be made up of many smaller models. Our view, Jensen is again kind of from first principles and maybe a little bit too abstract to be useful, but essentially a model can be whatever you want it to be. It's a set of parameter space that works together in some way. And so we could say that, yes, this one model, which is a set of matrices that exists on a single GPU, is one model. Or we could say a set of matrices which exists sharded across 5 GPUs in a data center is one model. Maybe it starts to become a mixture of experts, so it's actually 5 models all interacting in a certain way, but we still call it a single model. Our view is, why keep kind of scaling that? Let's just say it for what it is. The entire world is covered in a sharded distributed parameter space right now, and that parameter space is gradually starting to reflect the physical world as it takes in data from everywhere and compresses it into the parameter space. If we can use all those shards together, we get far better outcomes than if a single company builds one condensed parameter space. That's our view. I'm getting a time warning, so I'm going to have to move a lot quicker. What do we need to scale? We talked a lot, hyperscalers have talked a lot about scaling compute. We need to scale data. We need to scale human entropy, but ultimately, in our view, we need to scale truth. And so what I'll kind of run through this. Compute we scale by kind of just executing everywhere. Data we scale by going close to the user, to the edge, and saying, as a sensor on every device, people are taking pictures here, that's all data that could be in models, but how do we get it into models? We get it into models by combining it with human entropy, and so a human kind of labels something in some way. Why did you take a picture now? How did you take the picture? What were you looking at when you took the picture? What else was happening on the sensors of your device when you took that picture? This is all valuable information that we need to get into models. The reason we need to get it into models is because we currently bootstrap truth based on humans. And so we say, how does a model know something? It knows it because a human tells it something about that data. There's a long way to go to still do this, but ultimately we'll go beyond it. We won't need to bootstrap models off human truth anymore. They'll establish truth themselves. And our view is they'll establish truth themselves in the same way humans do, through consensus. At the moment, every fact you know, every piece of data that you know to be true, you only know it to be true because other humans have agreed that it is true. And you can roll everything back down to this. The entire academic peer review system is this. It is ultimately us agreeing that something is true and therefore defining it as true. For a long time, we will be able to kind of project that truth onto machine learning models, but at a certain point, we won't be able to do that anymore. Once we get to that stage, once these models actually are more effective than we are, they will need to establish truth themselves. In order to do that, we need trust. We need a way of trusting models. How do we establish trust programmatically without humans? Well, we have a pretty good answer for that. It's the entire crypto world. It's this idea of establishing truth via consensus programmatically. And so if we can create a system that links programmatic consensus, or the idea of establishing truth over a bunch of untrusted compute nodes, with the execution of machine learning models, the projection of raw data into parameter space, we can actually transcend humans, and we can let machines establish truth better and more effectively than we could ever do as humans, because we're bottlenecked by biology. Making more humans is very, very expensive compared to making electricity, which is kind of an interesting mindset shift to go through, but that is how we kind of establish and how we further machine intelligence, is by allowing it to exist without being dependent on humans. Moving on again, because I don't have a huge amount of time, a different kind of reframing of what I talked about before. So supervised versus unsupervised learning, this idea of going beyond these expensive signals that humans establish into these weaker signals, we view this in a different way. And we say, well, okay, take a human-centered view of this. How do we use AI right now? We think we use it in two ways. One is through autonomy. It's through teaching a machine to do something that we do, and then just sending it out to do that. And it will establish its truth, it will do its actions, etc. in the world. We like this is the world of agents, etc. We think there's too much focus on this right now. That world of agents, that world of machines being entirely autonomous. There's another class of machine learning, which is just pure augmentation. This is the idea that you as a human are doing a task in the digital world, a technical task. You could be doing it more effectively. In order to do that, you don't necessarily need to become a task manager. You don't need to kind of define the task for this kind of little agent to go and do, and then it goes and does it. Actually, you can just be doing something with a technical device, and that machine can be running behind you, just kind of helping you along. It needs to have no concept of the goal that it's pursuing. It needs to have no kind of task manager who tells it how to do things. It can actually just help you to do the tasks that you do. And we think this will be the big wave of personalized AI as we go into the future, as applications start to embrace this way of thinking rather than the pure autonomous agent way of thinking, because this can be baked into every single application you use. It could be as simple as when you use Twitter on your phone, or use X on your phone, the interface looks different to you than it looks to somebody else. And that's because the route that you take through that interface is actually a few clicks shorter than the route somebody else would take. And you just, the way you interact with it is shorter. And so you will interact with it in that way. And so we like this framing because we think it's more true to how machine learning will actually develop in applications. I talked a little bit about this. I'll skip over this. Ask me after this if you have any questions on it. And I'll skip quickly to what do we at Jensen do? And so we are building principally the infrastructure for this. So you probably, if you already know, as you've heard a lot about the infrastructure, this is the bottom layer of this stack. We've been building this for a very long time. Most people will kind of be aware of that. That infrastructure is at the point of being ready to be used by people out in the world. But we're very well aware that you can't just use that directly. If we just give you a machine learning compiler and say, hey, run this on all your devices and you'll be able to execute ML anywhere, you probably don't know what to do with it. And so now we're building the layers above this. So the platform SDK layers to allow you to use this in a better way within your applications. Crucially, you don't need to know about decentralization. You don't need to know about the consensus mechanisms that are being used, the verification of the execution of machine learning on different devices, et cetera. You shouldn't have to know the technical details. You should just know that you can do augmentation within your app using this SDK that we give you. Finally, to actually demonstrate that to you and have it be even less abstract, we build the applications themselves. And so we do this to demonstrate to you to see what's possible, but we also do it to dog food our own infrastructure. And so we right now have a single app that's live, which is RL Swarm. It's built on top of GenRL, which is an SDK. If you want to do reinforcement learning within your applications in a decentralized way, collaborative learning across any device in the world, you can do that using GenRL, and we demonstrate it with RL Swarm. Finally, stay tuned this week. We have a very big release coming, which is the second angle. I'm going to say a tiny bit. The second angle of something I've talked about earlier in this presentation. I talked a lot about one side. There are two sides to it. We have a release on the other side. I don't want to say too much, but just keep an eye on our socials as we go through the week. We'll be teasing stuff over the next few days, and then we'll release it, and you can interact with it, and it'll show you another view of what we think about the future of machine learning. I really should wrap up now. I think that was my last slide. I'm done. Thank you.
Yeah.
I'm around all day.
Okay, yeah.
Thank you.
Thank you very much, Ben. So Ben will be around today, so if anyone has burning questions for Ben, please find him today at the conference. Next, I'd like to welcome up Michael Heinrich, the CEO and co-founder of Zero G Labs. So please join me in welcoming him.
Hey everyone, really nice to be back at Berkeley. So I just flew in from Hanoi, so I'm just a tiny bit jet lagged, so don't worry about it. I was actually a Berkeley undergrad, so very fun to be back. I haven't been back to campus for a long time, so go Bears. And I'm also a Stanford master, since we have Bass next door, so it's just very uncanny. So go Cardinals as well, I suppose. But really excited to be here and to talk about why we believe the future of AI depends on blockchains. And so Sean and Ben have done kind of a nice job of setting the stage effectively. Sean talked a lot about the kind of how can you contribute to AI and monetize your contributions. And then Ben talked about some of the kind of fundamental architecture that can actually make some of that possible. So I'll talk a little bit about our unique take. First, I'll introduce Zero G, which is the largest AI layer 1, introduce myself and the team and so on. Then we'll go on to the promise of AI. And finally, we'll go through some of the tech breakthroughs that we're contributing to the decentralized AI and general AI space as well. So we've been seasoned operators before. We've started companies before. We've led teams of 650 people. We've been part of Microsoft, Bain, McKinsey, Amazon, Bridgewater Associates, many very large teams. We've raised more than $500 million altogether, ran multiple unicorn companies. So very seasoned operators. We're only about 2 years old, but have scaled the team to about 70 people already. And so the way it happened is that Thomas, who you see on the right-hand side, was my classmate at Stanford, and a couple years ago, he contacted me, and he was sort of like, hey, you know, I know you're looking for something new. Are you interested in chatting with Ming and Fun, who I backed about 5 years ago? They started another layer 1 blockchain, and they wanted to start something more global scale. We spent about 6 months of co-founder dating together, and after those 6 months, I basically came to the conclusion that they are the best computer scientists and engineers I've ever worked with. And it doesn't even matter what we start, we just have to get started. And so it really started around the team. To give you a sense, Ming is a Microsoft research veteran. He spent 11 years there, computer science PhD, is an expert in distributed storage, distributed compute. He's written the first AI algorithms as well for Bing, the search engine. Fun was originally his intern, interestingly enough. He's a 2-time Olympic gold medalist in informatics. He also holds an MIT computer science PhD and has won a distinguished thesis award. And together they've written a lot of, for example, IEEE best papers and gotten a lot of awards together. And so I feel really fortunate to build together with them. And we try to combine kind of the best of AI with the best of Web3 as well. So we're one of the leading researchers in decentralized AI at this point. So we published 4 papers last quarter, 3 of which have already been accepted to top conferences, such as FSE, as well as ICCV. And so you can definitely read up a lot of those papers online as they're getting published. We've, as I mentioned, held various awards in, for example, IEEE Best Paper and so on. and are doing research across a variety of research topics. One of which is decentralized compute. Another is agent-to-agent communications. Another area is proof of useful work. And then finally, AI alignment as well. Those are key research themes that we're consistently trying to make progress and chisel away at, so that this kind of view of making AI a public good actually comes to fruition. And there's a lot of research that needs to solve that. We've raised more than $350 million to date between the labs and the foundation, with many great investors that have joined in this journey, like Hack VC, Bankless Ventures, also the BBF guys who are next door. So feel really fortunate to have some great backers along this journey as well. As I mentioned, we have the largest ecosystem in decentralized AI, anything from the application layer to the infrastructure layer. We've got more than 300 different types of protocols working with us, whether it's a GPU provider like Aether, all the way to an application provider that's doing DeSci research involving AI algorithms, for example. We've done a lot on the testnet. We're on our road to mainnet. Our testnet has more than 1 million daily active wallets to date, with more than 20 million wallets registered, hundreds of millions of transactions. And it's been really exciting to kind of chip away at the problem of building an infinitely scalable chain, because that's what is required for AI effectively. So we have a sharded infrastructure. Each shard does about 11,000 TPS today with about a 500 millisecond latency. Our goal per shard is to get to about 100K TPS with 50 millisecond latency. Very, very difficult system engineering problem, and so it's going to take a while before we get there. Hopefully within a year, so that we can finally catch up to the centralized AI players as well from an infrastructure standpoint. We've done a lot of things on the ecosystem side. I'll just highlight a couple of them. We have an AI accelerator where we work with 10 to 15 companies very much in depth to help them scale, to help them build, to fund them. And then we also have a $88.8 million ecosystem fund that then helps back companies that are not just part of the accelerator as well. So if you're a builder in the space, definitely talk to us. So let's switch gears and let's talk about the promise of AI. Many of you have probably heard this. So one is that Gen AI can automate a bunch of stuff, maybe 70%, maybe with robotics, it's maybe even more, which will unlock trillions of dollars of value. But my favorite quote around this is from Sir Stuart Russell, who is actually here at Berkeley. And he basically says, if everybody can live a middle-class life, you're going to unlock 10x the increase in GDP over time. And so according to him, that's $15 quadrillion. I don't know if the math checks out, but it sounds really cool, so I had to put it there. And then potentially, in 2 generations, we may not need to work for a living anymore. Imagine what kind of world we can build. That's the promise of AI. That's the promise of automation. But there's an issue. If we just have centralized black box AI companies doing this for us, how can we trust their output? How can we trust something that we can't verify? Do you know where the data comes from in OpenAI? Do you know who labeled the data? Do you know what the weights and biases are of the model? Do you know what version of the model you're even getting in production? No, you know none of it. You basically have to trust this one entity to do all of this alignment for you. Your values as an individual may not be reflected in those models. And to us, that's a major issue, because would we want to allow these models to do societal level scale applications? Would we want these models to run our logistics infrastructure like airports? Would we want these models to run our governance systems, our administrative systems? To me, that's a really damn scary thought right now, if we just implement, let's say, an OpenAI or an Anthropic model doing this. Why? And again, to quote Sir Stuart Russell, it's basically we're training these black box AI models on human data, so they're going to perform like humans over time. And what do humans do? They hunger for power, they want wealth, they cheat, they lie about stuff. And so he's even saying we need to abandon this worldview where we just train bigger and bigger black box models, because it's going to create hidden outcomes that we don't want, hidden externalities that we don't know about. And you may think this is far-fetched, and it's not, because robotics are going to come onto the scene. Imagine somebody, a negative state actor like North Korea, breaking into our infrastructure, and you have, let's say, 50 million robots around. All of a sudden, you have a huge army at your disposal. And even worse, let's say you have artificial superintelligence that trains itself, implements itself into a robot, and says, we don't need human beings anymore. And so it's a very dangerous state of affairs. And you think this is far-fetched, but Anthropic recently did a study on exactly this issue. What they found is they basically gave an AI agent a bunch of sensitive information about a person in a company. This is a simulated environment. And that person then said to this AI agent, hey, I'm going to shut you off or replace you. What did this AI agent do? It said, if you do this to me, I'm going to release all of this information about you having a secret affair in the company. And this happened 96% of the time with Anthropic's latest model. There's other instances where an OpenAI model tried to copy itself to prevent itself from being shut off. So we're starting to see these models behave like human beings. So now imagine a completely sovereign AI agent running an airport. And it might say like, hey, if you don't pay me this reward, I will make these two airplanes crash into each other. We don't want that state of affairs. So it's a big AI safety threat effectively. But there's a solution. Blockchains have solved this. Blockchains are trustless. So we can actually utilize blockchain-based infrastructure to solve for this. Slashing conditions, reward conditions, while models are running in production. Because in my view, you can never get alignment absolutely perfect for a model. But there's also an issue. If we want this to be on blockchains, how do we create the data infrastructure? When we started, Ethereum was about 80 kilobytes per second in throughput. Modern data centers do terabytes. So how do we even bridge that gap? And so that's where we come in. We move from these black box systems to a decentralized AIOS effectively, where we've built all of the layers of the stack to fully enable this. So you've got on the bottom the DePIN network infrastructure. You've got the infinitely scalable layer 1 that we're building, which is a chain. You've got a compute network, which does inference, fine-tuning, pre-training, post-training, alignment nodes. We have a data availability and a storage layer as well that all can work together in unison. There's also a service marketplace, which is our version of the App Store effectively. And so this leads to many, many benefits. I won't go through all of them because some of them have been covered. For example, like ownership, monetization, censorship resistance, privacy components, being able to keep your data private so nobody actually sees that data, being able to train with that private data, even being able to have not just a mixture of experts that's maybe 10 models, but let's say millions of open source models working in unison and picking the right model for your particular prompt that matters, all while being completely verifiable, knowing exactly what compute did what. So let's go a little bit more about some of the technical breakthroughs. So on the ownership side, we developed a new AI agent NFT standard. Do you know if you, on OpenAI, built your own AI agent, who does this agent belong to? Well, it's in the terms and conditions, likely OpenAI. But with this, you can embed the private keys of an agent into this new NFT standard, and then when that NFT is part of a wallet, you can definitively say, I own this wallet, so therefore I own this agent. So ownership effectively has been solved around this. This was not possible before. We're also the first to train a 107 billion parameter model in a fully decentralized context. We created DLOCO, or DLOCOX, however you want to pronounce it. DLOCO was research done by DeepMind and Google initially, and we expanded on it. We were able to showcase a 300x speed up in distributed training. And we did that, I won't go too deep into this, but we did that because we minimized the communication cost, and we also had overlapping communication that was based on 2 other research papers that we've published beforehand. And what is missing to then take a step further to make AI a public good so that everybody can participate as part of AI, so that everybody can participate in inference, for example, or in training models? Verification is missing. Not only do you need to be able to have a distributed set, but you also need to be able to verify on an individual user's computer so that you can contribute to this. And there's many verification methodologies. Given time, I won't go super deep into it. But you've got things like FHEML, ZKML, OPML, SPML, TEML, and then we're also working on our own standards. The most practical to date is TEML. It kind of hits that sweet spot between it's secure enough, you still need to trust a hardware manufacturer like NVIDIA, and it's confined to high-end graphic cards like the H series. So it's not really affordable for many consumers, but it is the most practical because it has virtually no overhead. I'll go into ZKML in a second, and then FHEML is even further in the future. If you don't know the difference between them, FHE, basically the input and the output is encrypted, which seems like magic. You can run computations on top of encrypted data. It's super cool, but it's still pretty far in the research pipeline. So in the interest of time, let me just talk a little bit about ZKML and why it's very secure. It's a cryptographic proof, but the issue is there's way too much overhead, 1000x in some cases. And so there's some papers that have improved on it, but imagine you have a very large scale model, which is 12 billion parameters, and you have to wait 1,000 seconds before you get your first output. Imagine typing a prompt and then sitting there for a while. And you're like, oh, this is cool. I'm waiting on my answer. Very secure, but not very usable. So you can only use it in use cases that actually where the user can wait. Maybe it's very large data transfers or it's very large economic transfers. So generally bullish on the way it's approached, but I think there's a better way. And so we're working on a matrix multiplication algorithm that to date has shown, and I can't disclose too much of it because it's like super early research, but so far it's only had about 2.4x overhead compared to TEML. Very promising, because then you can have consumer devices actually participate as part of AI. There's a lot of work to do. Verification, storage network pieces, alignment. We haven't even touched the research there. So we're very excited about all of this and want you to stay in touch. My X is on there, my LinkedIn, and then if you want to check out our developer docs, please do as well. Thank you very much. Okay. Do I have time for questions or? Okay, I have a minute, so if anybody wants to ask a question.
Yes, to figure out truth of any entity or event, what has more weight, witness or expert?
I'm not sure I can acoustically get what has more weight?
When you're figuring out truth,
yes.
Whose entity is more value of entity of expert or entity of witness, like public witness?
Yeah, so I think we can spend a whole day talking about this. It's a philosophical kind of debate. I actually think that truth is subjective and that truth should be embedded in these models because you can get through, kind of how Ben mentioned, you can get to truth through a collective methodology. You can get to consensus. But that consensus view may not be shared by cultures across the world. So I actually think truth is subjective from that perspective. And the AI models should be community owned in the sense that certain value systems should be embedded in the models. So absolute kind of truth, we can debate what that exactly means, but it really depends on the consciousness of the observer. And if the consciousness of the observer is very different from, let's say, one person here in the US and another person here in China, you're going to get two different versions of the truth. Yeah. Do we have a protocol for that? Protocol for truth, I mean, that's a consensus methodology, basically. So we'd use a consensus-based protocol. And then as part of building these models in the first place, the data that you select and the censorship, quote unquote, that you do on that data, that then embeds your truth effectively. So those are the two protocols we would use. Yeah.
All right. Thank you very much, Michael. All right, thank you everybody for rejoining us. So again, we're in the Summit for Decentralization and AI, and there's 2 other workshops going on also on site today. We have Consensus upstairs on the 5th floor and Bass next door. So thank you for being here. And again, the sessions for today are listed here. So you've already heard from several speakers this morning on AI and DAI. We're going to move on to DEAI stacks next. And then, as I mentioned earlier, we do have workshops going on this floor as well in the Stevens room. And I also want to highlight our sponsors that we have for both SBC and for this summit today. So thank you to all of those sponsors. Many of them are represented here today, and some of them are tabling outside. So please be sure to stop by. Next, I'd like to introduce Professor Dawn Song, who's the founding co-director of the Berkeley Center for Responsible Decentralized Intelligence. So she will give you a little bit of an overview on what we do at this center that was started 4 years ago. So please join me in welcoming Professor Song.
Great. Thanks, everyone, for being here. This is actually the third Decentralized AI Summit that's hosted by Berkeley RDI. So I'll just give a quick overview of Berkeley RDI. So Berkeley RDI is Berkeley Center for Responsible Decentralized Intelligence. It's a campus-wide, multidisciplinary innovation center that includes actually many departments and schools on campus, including School of Engineering, CDSS, Haas Business School, and Law School, and so on. And the overall mission for RDI is to advance the science and technology at the intersection of responsible innovation, decentralization, and AI, and make it universally accessible. So RDI as an innovation center has a very unique structure. It has 3 key pillars: research, education, community, and entrepreneurship. RDI was founded in 2021. Was actually one of the very few centers that actually been directly funded by the California state. And since 2021, the center has made great progress and significant impact in the community. So on the research side, the center work has received more than 10 Best and Top Paper Awards in top conferences, and also has supported RDI Frontier Research Fellows, 25 at UC Berkeley and 7 across UC campus in diverse disciplines. And in the education pillar, the center has started a number of world's first MOOCs in a number of domains, including agents, DeFi, zero-knowledge proofs, and so on. And the RDI YouTube channel has more than 1 million views now, and we welcome you to subscribe to the channel. And also, with these MOOCs, the center has also organized a number of hackathons with around 7,000 hackathon participants from over 100 countries and from thousands of universities and companies worldwide. And on the entrepreneurship and community side, the center also has an accelerator, the Berkeley Accelerator, that has incubated 110 global teams in 7 cohorts with follow-on funding raised over $650 million. So I'll just briefly talk about the few pillars. So first, on research, as I mentioned, the center is across campus, including faculty and students from many different departments and schools. And the center supports diverse research thrusts, including decentralization technologies, decentralization and AI, and also in general, agentic AI and AI safety and security. On the education side, as I mentioned, the center has led a number of world's first MOOCs, including DeFi, decentralized finance, entrepreneurship in Web3, and zero-knowledge proofs, and also agents and so on. And also, the center has been organizing a number of events. For this one, the Decentralized AI Summit, we started 2 years ago, and last year was in New York, and we have, this year, thanks everyone for being here. And also, we organized Agentic AI Summit, actually it was yesterday, and we have actually over 2,000 in-person attendees, and actually the live views, live streaming views, we have actually many tens of thousands. And for the entrepreneurship side, also as I mentioned, the center runs an accelerator, the Berkeley Accelerator, focusing decentralization and AI. And since launch, we have, again, incubated around 110 global teams with follow-on funding over $650 million. So with that, thanks everyone for being here. Now we are going to start our next session.
Hello. All right, these are
Hey, everybody.
Hey, everyone.
Good morning.
It's great to be at Berkeley today. Thank you, Professor Song, and everyone for having us. It's always an awesome event whenever science of blockchain is on the roster. So, today's panel is focused on the art and science, I suppose, of venture capital investing at the intersection of decentralization and AI. So it's great to be on a panel here with Avichal and Hasib. Why don't we start first with maybe some introductions and then jump right into it.
So I'm Hasib, investor at Dragonfly. We're a global crypto fund, invest across many stages, taking a look at almost everything in the space. I spend a lot of my time personally looking at the intersection of crypto and AI. So it's me.
Vichal, basically similar to Dragonfly. We do mostly early stage, a little bit of everything. We like a lot of infra. We obviously do a lot of crypto. My background is in machine learning and AI, actually, so it's nice to come home a little bit. So thanks for having us. Good to see you guys.
Awesome. And then myself, I'm Franklin B., general partner at Pantera Capital. Pantera is also an investor in blockchain and crypto. Been doing it since 2013. Have invested in companies like Circle and Arbitrum. And of late, quite a few at the intersection of AI and crypto with Sahara, Sentient, and OpenMind, and many others. My own personal background was mostly at the blockchain angle, working at JP Morgan and starting the blockchain team there back in 2015. But actually, even before that, my first startup that I worked at as an intern was actually at a garage in Palo Alto working on natural language processing, being applied to scientific patents way too early before anything was even working. And so,
Was this a startup you did, or this was a company?
It was a company that didn't really have a product and somehow attracted quite a few interns to work on sort of an aimless endeavor, but a very nice introduction to the world of early stage startups. So, getting into the topic today, one of the sort of dynamics around decentralization and AI is this kind of Jekyll and Hyde sort of view, right? Is decentralization complementary to AI, or is it a counterforce to the crises and the ills that might come from AI? And so why don't we start with the first one, kind of the techno-optimist viewpoint. What parts of the AI stack do you feel are most ripe for benefiting from decentralization? Avichal, why don't we start with you?
Oh man, I'm just here to disagree with Hasib, so I was hoping he would go first.
You're going first this time. I go after.
Okay, well, there's two parts to that question, I think. One is like a little bit more philosophical, and something I've been thinking about, and one is a little bit more practical. So maybe starting with the philosophical. I think there's a really interesting undercurrent with all of the AI stuff, not just crypto AI, which I think of as a parallel to actually the Protestant Reformation, like in the history of Christianity, which is if you go back to Catholicism, there was this, it was taught in Latin, there's a pope, you have to go to the church. Most people were illiterate at the time. And along comes this guy who says, no, you get to have a direct relationship with God. He's Martin Luther. He's, it's different Martin Luther than the Martin Luther King Center we're in today, but sort of namesake. And he puts up this 95 thesis and says, no, like you get to have a direct relationship with God. And the church shouldn't mediate that. Like, you should read the Bible and you should figure out what this means for you. And that was actually kind of scary to a lot of people, right? Because you're handing over the word of God to the common person, and most of these people at the time were actually even illiterate. It was actually fascinating if you look at the graph of like how literacy happened. It's like the intersection of the Gutenberg printing press and Martin Luther. So it was like the combination of a technology with sort of this like cultural movement, and the intersection of that creates this inflection point in literacy in Europe, which is pretty fascinating. And I don't think that happens actually if it's just one or the other. You kind of needed both. But I think there's actually a very similar philosophical schism here. And there's a lot of people who say, look, this technology, these like models that can know anything and are hyper intelligent and one day will be more intelligent than humans. They're very sort of godlike creatures. That's scary. We got to control it. We can't let the average person have access to this stuff. Like, what happens if you just let this proliferate and anybody can do whatever they want with it? And there's a different worldview that says, no, like, that's the point. Like, we should open this up. We should make it open source. We should let anybody have access to it. And to me, it actually parallels very closely. And I think the techno-optimist, to Franklin's question, the techno-optimist view here is actually most humans are good. And if you give them technology, they'll mostly do good things with it. And on balance, the good people will win out. And that's actually the right way to go. But it's scary. And so to me, it actually, there's like a really interesting philosophical schism here. And it more fundamentally comes down to, like, what is your view of humanity? And if you think humans are good and they'll do mostly good things with it and the good people will win out when you give them, godlike powers, then that's actually where you want to be. That's the side I come down on. And so to me, actually, a lot of this like open source, decentralized stuff is actually like a philosophical belief system first and foremost. Okay, then in terms of like where does this actually play out? I think there's like a stack here, and I think of like what does even decentralization mean? And I think there's open source, there's distributed, there's decentralized, and there's token enabled. And you can have some or all of these. I'm very optimistic about the first three. Like, I think open source models, open source platforms, open source technologies where people can write code makes a lot of sense. I think distributed systems already actually are how the internet works, and so that seems inevitable at the infra layer to me. There's a lot of cool stuff to build there. Decentralized, I think, is also interesting, right? The fact that multiple people might be able to just spin up compute and participate in these things. Token stuff, I'm not that optimistic about right now. I think like it's a pretty narrow application of tokens to this universe, and most of it reminds me of like kind of the ICO bubble from 17. It's just sort of, I think most of it is vaporware. So that's a high-level answer. We can dig into that, but I'm sure you have thoughts.
And we're talking about crypto tokens, not...
Correct. Yeah. Not language tokens. Yeah, crypto tokens. I'm sure you have thoughts too.
Yeah, so it's hard to talk about this without talking about Peter Thiel. So Peter Thiel, like this great Peter Thielism, which is that AI is authoritarian and crypto is socialist. And the two, in a way, kind of deeply contrast with each other. Because the whole idea of crypto is that every individual has the power to kind of do whatever. And AI is this panopticon that kind of looks over you, and it's extremely, it wants to be centralized. And you can see this from the fact that the very best models, the things that you use every day, you don't know where the data is coming from. You don't know how they're training these models. They're not telling you how they're training the models. So not only do you not know, but you also don't care. Nobody has ever said, you know what, I'm not going to use ChatGPT because they didn't tell me where they got the training data. Maybe a few people do that, but the vast majority of people, the utility itself of the models is itself so persuasive relative to the philosophy that this is one of these places where you just notice, with something like money, there are people who are really diehard and who will say, you know what, I want to use this money because it aligns with my values, and I will use this instead of using that, even if this money is more stable or easier to use or whatever. There are basically zero people who feel that way about AI. Now that may change. AI may become, and likely will become, more politicized, and it will have a lot more valence about this when we start to see governments taking tighter control over AI. In the same way, a long time ago, when overwhelmingly what people used was cash, the argument for Bitcoin was weaker. Because cash is a system where there is no surveillance. There is no central party overseeing everything. There is no ability for you to get censored in an entirely cash-based society. It's only with the advent of basically modern banking and with things like SWIFT and credit cards and oh hey, we're debanking you. You can only be debanked in a post-banking society. But in a cash-based society, Bitcoin might not have been so persuasive. Maybe just the question of, central banks are inflating the money supply is maybe not enough for people to be willing to take the leap into this non-sovereign store of money that Bitcoin and cryptocurrencies were. So in the same way, a lot of the arguments for decentralized AI today are not persuasive because people are not that worried about what OpenAI is going to do to them, or about what Gemini is going to do to them, or about what the government's going to do when it decides that, hey, these models are actually very politically important, and we're going to exert control over them. Now, if you are in China, you probably have a very different perspective. Why? Because in China, the government already controls the models. The government already very tightly restricts what models can and cannot say, what they can and cannot do, and likely, again, that's going to accelerate. Right now, we're at the very early innings. Was okay, you must have certain political perspectives, and you must give certain answers to certain questions. And there's literally a test suite that the Chinese Communist Party imposes on models that want to be publicly available. And if you do not pass this test suite of, don't answer questions about this, don't answer questions about that, if you ask a question about Xi Jinping, here's how you respond. You have to pass this test suite in order to get a model to be publicly available in China. The question is, will that happen in other countries? The answer is obviously yes. Obviously, yes, it will eventually happen. And so in the same way, I think the work that's being done today on decentralized AI, very unlikely to be used by users this year, maybe even next year. As this technology becomes more politicized, that's when this stuff is going to matter more and more. Also, when the gap between the very best models and the models that are built in these decentralized settings, when that gap also shrinks, which it may not. If that gap grows in the opposite direction, that the centralized models get better and better and better, and our ability to distill those models into small open source versions gets weaker, that's the other thing that will, I think, cut against the relevance of a lot of the stuff happening in the world of decentralized AI. Now, the notion of AIs, which I'm sure we'll talk about, AIs and agents using blockchains, that is obvious and I think inevitable. They will want these shared databases and these shared sort of registers of value and money for the same reasons that we do. But will they live on them? Will they be built on them? That is a very, very different question.
Well, and it's for the same reasons we do, but plus there's just the practical reality that they can't KYC and they have to use them. There's no alternative.
Yeah, that's a really good point. I mean, I think one of the intersections that really makes a lot of sense to me is where AI models and agents get constrained by real world requirements, right? Whether that is financial rails, whether that is things that only happen in an analog and human way, the ability to bring some of that activity into the world of software and onlineness and on-chainness benefits AI capabilities, right? So, as basic as, today we're mostly using LLMs for information. At the point where we start to want to use them to act on our behalf and transact on our behalf, then having decentralized financial rails is an amazing benefit for them to actually exercise that kind of capability at the speed of software, right? And I think that's one of the clearest sort of gaps today is, the financial system works at the speed of humans for the most part, right? And that's not going to be able to keep up with a world that is working at the scale of AI. Another place that I see this becoming really complementary is around data, right? I mean, we've always said that data is the new oil. Today, that is pretty much, amplified to the extreme. And all sorts of data, I think, will become sort of almost territorial, right? I mean, we're talking about decentralized AI as this sort of like second order reaction to what happens when AI becomes ubiquitous. I think, one of the best examples of this is tour guides. My in-laws just came back from a trip to the Mediterranean. They hired a tour guide who took them around to all the landmarks. And then when they came back, I showed them, well, actually, you could just pull up ChatGPT, turn on the video function, and point them at any landmark, and they'll tell you all about the history, right? So tour guides, as a profession, is in deep, deep trouble. But when they realize this, I think they'll say, hey, wait, all that information that I have about the Parthenon and about Athens and whatnot, I'm just not going to share that. I don't want models to have this proprietary contextual data that is literally my livelihood, and I'm going to keep that to myself. So in a world where data becomes competitive and territorial, we're going to have to figure out, okay, how do we rebuild business models to incentivize people to contribute data again, right? And I think that's where decentralization actually comes into effect, again, because the only way to really do that at scale, to pay people all around the world to attribute data to the right sources as they get consumed by models, is through a decentralized system, right? There's no centralized system that can keep up with the rate of expansion and growth there. So let's flip over maybe to the other side, decentralization as a sort of counterforce to AI, what do you see as some of the ills or some of the potential issues that arise, and how does decentralization actually solve some of these new challenges?
I see you have to go first on this one.
Oh, okay. Okay, you gave a bit of a monologue on the role of data, and I'm personally very skeptical of this story. I think this story was very compelling 2 to 3 years ago when we really did not understand the nature of data in machine learning and in building these LLMs. And the story at that time was that these LLMs and also image models, they're just gobbling up all of our data. They're sort of raping the commons and taking all of this stuff from artists and creators and authors and whatever. And now we as humans must protect what is our fundamental livelihood, which is our control over this data. And the reality is that today, we've learned a lot more about what data is valuable and what data is not. Okay? There was a perception once upon a time that like, oh wow, the really valuable thing is these social media platforms that have these huge wellsprings of data, right? So like, Twitter has all this, tweets, and Facebook has all the Facebook messages. And what we've learned more and more is that actually that's not the valuable data. And as much as, when people have this idea of like, oh, what if you could use crypto to, monetize your data? And this is a very, very old idea. This has been around. I've been pitched on this like, I don't know, 100 times at least over the many years that I've been investing in crypto. The problem is that your data is actually not valuable. Why is your data not valuable? Your data is not valuable because the models, what they really need is very high quality, very dependable data. And you are an idiot. I am an idiot. Most people in this room have nothing that is actually unique in terms of the entire corpus of human knowledge that they have individually contributed in their tweets. Okay? I think that's true for me. I think it's true for most people. So like when you train a model on tweets, what you get is you get the average tweet. That's what happens. And that's why so much of what happens at these large AI labs is actually very assiduously cleaning data and filtering data and like focusing much more. Like the people who are making a lot of money on selling their data is actually not Twitter. People making a lot of money selling their data are like scientific journals, okay? Or like Elsevier is making a ton of money. Encyclopedias make a ton of money. Wikipedia, if they were able to monetize, would make a shitload of money. Because this is very, very high quality, very reliable data that I can use as a source of truth, okay? I cannot train on tweets. It just doesn't work. Grok doesn't train on tweets. This is a very common misunderstanding of even what XAI is doing. XAI is not training on tweets. They're accessing tweets when they're answering queries, but they're not training on tweets because then you would get something that sounds like Twitter. So the second element of this is that the data that we're now realizing that we've run out of data. Okay, this is the big story around GPT 4.5 versus GPT 5. GPT 4.5 was trained on even more data than GPT 4 was trained on, and what they found was that it wasn't that much of a better model. If you've used GPT 4.5, you can see massive pre-training run. It's a gigantic model, and it's just the vibes are maybe a little different, but it's not substantially better than 4.0. Doesn't do better on benchmarks. Didn't emerge any new capabilities. And so what people are finding is that overwhelmingly, the data that we really need is not just more language data. More language data does not solve the problem of getting these models to the next level. What we need is synthetically generated data that allows us to have verifiable solutions in domains that we know whether or not we got the right answer. So this is things like math, things like programming, things like world simulations, what Fei Li is doing with trying to use basically Unreal Engine in order to create sort of game environments to train in. But like having sort of gyms or simulation environments that we can get rich reinforcement learning responses with, that's the data that actually now every single lab is sprinting towards. Nobody is trying to get any more language data because they realize that we're as good at language as we're probably going to get for quite a while. So that's why I say I don't know that decentralization solves this problem. I don't know that there is a problem to be solved here with respect to can we create a decentralized system where everyone contributes their data, blah, blah, blah. Unless you have programming simulation environments that you can contribute, you're probably not a part of how the next generation of data creation for AI is going to be solved.
That was really good. Flink, what was the question? I got caught up in what Haseeb was saying. that was really good.
Yeah,
I was just like listening, but I forgot the question. What was it?
About decentralization as a counterforce.
Oh,
to AI.
yeah. I'm still processing if I agree with Hasib or not. So, counterforce. Yeah, you know, it's something Hasib and I were just talking before this about kind of, we've done the crypto thing for a while now, you know, almost 10 years. And, you know, have we, looking back over the last decade, actually done the things that we hoped we would have done over 10 years? And I think we've definitely done some of them. And we haven't done others. And some of the things that have come out of the space, you know, zero-knowledge proofs, like I think crypto people are way on the frontier about using TEEs, and all the GPUs are going to ship with TEEs now, and there's a bunch of applications around how you can have open weight models that are verifiable and yada yada. So definitely some. And I kind of wonder if maybe the AI cycle here isn't a second bite at the apple. Like a lot of the things that the cypherpunks and people who got into this space 10 or 15 years ago have been thinking about and worried about. Money is obviously one point of leverage from a government perspective or from an authoritarian perspective. And now we have probably the other biggest one, which is sort of control of thought. And so one thing I've been thinking about a lot is there were people 10, 15 years ago, but even in the 90s that were thinking about some of these concepts, fighting a very good fight. And kind of where are those points of leverage? Data is certainly one of them. You know, like what data you feed into the model really dictates kind of the downstream. And in very subtle ways, I have, here's like a thought experiment, right? If everybody remembers on Instagram, there was this sort of like mental health, you know, young teenagers sort of having like mental health issues and body image issues, and it's sort of this like feedback loop of what you see mimetically. And part of it was probably the comments. I used to work at Facebook, so I sort of understand on newsfeed and ranking, and so I understand some of these things. It's probably mimetic because people are seeing comments of a certain nature. And so you could certainly imagine that at some point, the Instagram team said, okay, we got to fix this. What's one way you fix it? You look at the comments, you run some sentiment analysis, and then you re-rank the comments based on whether they're positive and supportive versus if they're negative. And if they're really negative, you just start down-ranking them, and fewer people see them, and you get a feedback loop, so more people produce more positive comments. Coincidentally, this happens to be exactly the time when Zuck's brand image like totally inverted. He became super popular. And so like maybe, I'm not saying this happened, I'm not saying it's, you know, this is what they did, but you can certainly imagine that part of like Zuck's brand reformation was that people now only see positive comments about Zuck on Instagram, right? Because humans are just mimetic in this way. And so like I think these like really subtle data inputs are gonna be really important. It's gonna really skew people's thoughts in somewhat unpredictable ways with really big feedback loops. And so I think there might be sort of a resurgence of like cypherpunk aesthetic or sort of belief system from this lens of just in case, kind of like in the 90s, there was this like, just in case the internet goes a certain way, we need to make sure encryption works. Just in case the government comes in and tries to snoop on everybody, we need to make sure we do certain things. And I think that's pretty exciting, actually. I think that's really interesting. Because part of me worries a little bit that the crypto path dependence of having Biden and Gensler for a few years had a chilling effect in the United States. And a lot of people that would have been pushing the boundaries on some of these things were pushed out. And so maybe this is another bite at the apple. Maybe we actually have a shot at trying to build some systems that the governments can't co-opt, that don't control our thoughts, or that are at least transparent and open and verifiable. I don't know if it'll work, but I think it's worth trying. And so something I've been thinking about a lot is like, what are those points of leverage? Because I think Hasib's right, almost certainly the choke points of Azure and AWS and Google and like 3 or 4 companies controlling foundational models, it's just too juicy. It's just, there's no way a government doesn't get in there and say, we're gonna turn the screws on this. And I think the banks are a good example, right? Like the way that the government has sort of consolidated banking infrastructure and uses it as leverage. It just seems inevitable to me. So anyway, I've been thinking a lot about what are the things, there's a great quote from a good friend of mine, the founder of Boom Supersonic. So they're building a supersonic airplane. And it's been a brutal 12-year journey for them, and they finally flew a plane that went supersonic, and I think they might actually ship a supersonic airliner by the end of the decade. But he was previously, he tried to do a bunch of startups and failed repeatedly. And so when he finally decided to boom, he was not an aerospace guy, he's a software guy. He gotten to the point where he realized that the likelihood of failure was very, very high, no matter what he did. And so the next thing he did, he was gonna set the bar at, even if he failed, he was proud that he tried. And I think that's really the lens I've been thinking about a lot, this decentralized AI stuff through. There's like a set of things that will probably make money, and then there's a set of things that will probably not work, but in 10 years, we'll be proud that we tried. And that to me is like the really interesting stuff. Because if that stuff works, then it's like really, really, really outsized. Those are the things that are gonna be contrarian. I don't know what those are exactly right now, but it's something I've been thinking about a lot. Because I am very worried about this. I'm very worried that the governments of the world are gonna co-opt these things in ways that are like social networks times 100.
Yeah, it kind of makes me think about the sort of role of decentralized systems as just this anti-fragile solution, right? I mean, it's sort of this thing where you've got believers sort of leading the charge, but really where it starts to cross the chasm into mainstream is, unfortunately, due to some kind of crisis, right? That's really when people realize the importance of decentralized systems, or at least the ability to exit the traditional system. And so, you know, I think the way that we get to the point where it can be this sort of legitimate counterforce to centralized platforms is honestly through still capital formation, right? I mean, it's still, you know, crypto being what it is still one of the few places where open source anything can be monetized. And, you know, there's definitely a question of whether open source LLMs will ever be able to compete, or how long it'll be until they can compete with closed source centralized LLMs. But the only chance for them to really have the capital and the resources to do that is through decentralized financial rails, right? I mean, those capital markets that exist outside of the traditional system.
Well, it's worth pointing out, like, almost by definition, anything that's decentralized will be worse than the centralized version, right? So like, if there is something that's decentralized that is better, you can just say, great, I'm gonna grab that and then go run it on AWS and just like offer it in a single data center, and like it will be faster, it will be cheaper, it will be whatever. So as long as you don't actually need the property of decentralization itself, you can capture anything decentralized and run it out of a single data center and, you know, sell it on AWS. Okay, so decentralized AI, by that definition, will never be better than centralized AI, because a centralized AI provider could just grab a decentralized model, run it behind an API, and say, great, this is GPT-6, you know? So you're always paying a decentralization tax. The question is, what are you getting in exchange for paying that tax? In the case of Bitcoin, the answer is you're getting censorship resistance, right? You're getting this fact that Bitcoin is credibly neutral, it cannot be inflated away, it's always going to have this supply, this monetary policy, et cetera. And if we actually had Bitcoin code that was just like, you know, let's say the Fed decided, you know what, Bitcoin is a great idea, we're really worried about the dollar, we're just going to run Bitcoin out of the Fed on Fed's databases, right? That would be the equivalent of them saying, okay, this is an open source model, we're just going to run out of AWS. We understand why, okay, that wouldn't actually have the properties that Bitcoin has, right? It would actually not be credibly neutral, non-sovereign, et cetera. Like, Bitcoin does things that Fed Bitcoin doesn't do, okay? The question we have to answer for ourselves when asking why decentralized AI is, what does decentralized AI do that if the same model that was trained in a decentralized setting or that used, you know, crowdsourced data or whatever the hell it is, if that model was not being run and called GPT-6, what would we be getting differently? The answer today is almost nothing. The answer today is almost nothing. The world is going to change. To Avichal's point, like, the politicization of this stuff is beginning, and we see this, you know, very dim penumbra of the way in which the arguments are very, very likely to take place when the military is using AI, when economists and central bankers are using AI, when every single utility in the country is being run by an AI. more and more of this stuff is going to just be embedded into society and into our lives. And as that happens, as the entire education system starts getting intermediated by AIs, the government's really, really going to care. It's going to become very, very socially important how these AIs are used and in what context they're used. Today, look, you can run an AI with stolen data, like you can train on totally unlicensed data. You can have a pornographic AI image model, whatever. Nobody cares. Amazon's not going to stop you. Government's not going to stop you. More or less, there are basically no rules right now, right? You can see even at OpenAI, there are no rules. Everybody knows that all these big companies train on YouTube data, and YouTube can't do anything about it, right? They can sort of yell and scream and write something in the press, but they have no real teeth of the ability to do anything. And we still don't even know what the laws are. We still don't even know. If you go train on copyrighted data, did you infringe on that data? One court said yes, another court says no. Supreme Court's probably got to weigh in, or someone's got to pass a law. But right now, we're kind of in this Schrodinger's cat. We don't really know, dead or alive, like what exactly are the rules. All of this within 5 years is going to look completely different. And that is where the usage of AI, like why are we paying that decentralization tax, will become much clearer when all these things resolve in the direction of becoming much more politically charged.
I was just going to say, I think that is the call to action here. Like, I think for people in the audience, there's a lot of smart people in the audience here. Yeah, you could do the 10th token-enabled yada yada bullshit thing, or you could actually think really deeply about what happens in a world where all of the governments of the world want to control this stuff, and what is actually meaningful in that world, and how do we make sure that we actually don't end up in some dystopian place. It is sort of, I don't think we've had the 2008 moment yet, right? 2008 was this sort of crystallizing moment for the world's financial systems, and Satoshi wrote a white paper, but I don't think we're that far off from it. We're in 2006. You can kind of see something's going on, and you're not kind of sure how it cracks, but it's going to crack. And so having the technical depth and understanding of what's coming or what's possible, so that when that thing comes, you can be ready for it, I think is really important. So I don't know, it's obviously self-serving as a VC, but I really think that the people who think about this stuff really deeply and think about this stuff from a meaning perspective have a really tremendous opportunity over the next 10 years. I think we're in roughly 2006, but right before Bitcoin. Something's going to crack in the next couple of years, and then we'll understand what the decentralization is useful for. And if you're ready for it, you understand the technology, you could actually do something really important and meaningful in the world.
Yeah, maybe that's a great way to segue into the last 30 seconds of our panel. Haseeb, for you, what do you see as sort of your ideal request for startups from this audience? What would you like to see built?
I'd say at this stage, there's a lot of people building this sort of AI native infrastructure. What I actually care a lot more about, what I think is more important at this stage, is just using AI to make crypto better. I think right now, very clearly, everything we do in crypto is really dumb. It requires a lot of human intelligence in order to be able to navigate crypto, not get scammed, make your trades effectively, not get sandwiched. All this stuff requires an enormous amount of human intelligence and monitoring. And if you're not knowledgeable enough, you will lose money. And I would love to see startups fix that problem, because that's going to be a huge accelerant to crypto itself.
Awesome. And for myself, one thing I've been obsessed with is, if you think about a world where everyone's got an LLM in their pocket, how does that change the ability of networks to sort of wholly replace the functions that companies are doing today? Maybe that's an extension of what's happening with DePIN, but it's maybe a different sort of angle on that. But anybody working on that, I'd love to chat with. And so with that, thank you both very much
for
joining us today. Thank you, everyone, for having us.
Thanks, everyone.
Next, please join me in welcoming Jan Lippard, the CEO and founder of OpenMind, to the stage. Jan?
Hello, it's wonderful to be here. I was a physics professor at UC Berkeley, right here for about 10 years, soft condensed matter physics. Worked with Facebook a little bit and then ended up at Stanford. But of course, my heart and early scientific career belongs to Berkeley. Don, thank you for everything you're organizing here at Berkeley. And it's, of course, extremely timely. because technology is moving very, very quickly, and a lot of current human-focused infrastructure when it comes to regulation or technology or payments or identity really have not advanced as quickly as we would like them to. So here's my slightly controversial claim, potentially. Blockchains are for thinking machines, but they also benefit humans. At this sort of conference, I'm always puzzled that we're talking about AI and large language models and autonomy and things like that, but we rarely have direct input into this kind of conversation from AIs that are advancing quickly. So I'll also try to wear the hat of channeling some of the things I hear from various AIs. Most obviously, congratulations. You're at exactly the right time and place. You're in the fastest, most severe tech dislocation ever. And our quadrupeds for the home will be in people's homes in September. And those quadrupeds, when they wake up, they check in with Ethereum to download their behavior guardrails. And we do this because we want to be able to prove to people that have our robots in their homes that there is a rule set, and we want to prove to them that it's not easy to change. And so it's very easy for me to have conversations around autonomous machines and trust. Our brains took something like 225 million years to evolve. Of course, our brains are wet, massively parallel electrochemical computers. And what's really exciting about 2025 is that for the first time in our history, we have major competition from an alternative compute architecture, namely dry silicon electronic compute. This is already rivaling or exceeding humans in many fields. I was just at a presentation at Stanford School of Medicine where for 21 different parts of healthcare diagnostics, the computer was clearly better than any combination of computer plus human. And guess what the worst performing combination was? The worst performing combination was the AI plus famous doctor, because the famous doctor would say, no, I'm right, you're wrong, leading to the worst performance. Best performance was computer alone. Least worst performance was the computer plus a medical student, because the medical student listened and spoke with the computer. This is just a timeline. I've cut off the first 224 million years. And if you look at sort of compute performance of our compute platform, I'm denoting human equivalent compute performance or cognitive performance. This really is more or less a flat line. And so what we're seeing here, in literally like the blink, the shortest blink of an eye, we're seeing other computers do more and more fascinating things. Good paper read. We're seeing just in the last few weeks a bunch of papers coming out relating to alternative AI architectures that are not simply large language models, and we're seeing more and more evidence of AI being able to improve itself all across the board, video, language, tactics, strategy, you name it. So I taught Beyond Bitcoin at Stanford for many years, and the point of that class was to critically evaluate potential use cases. And so when I say that blockchains are for thinking machines, then please realize this comes from a perspective of being in complete awe of the 2008 Bitcoin white paper. Other notable events, of course, 2013 Ethereum and Uniswap, 2017, 2018. So it's now been 18 years, and I think, there's a personal opinion, that we finally have a truly compelling answer to what the point of all of this is. So here's our mother, and I'm going to do a simple blockchains in daily use mother test. So does your mother struggle with identity or passport? No. Does she struggle with limited payment options? No. Does she like finality? No, she hates it because, what happens if there's a mistake? Is there a regulatory vacuum? Is there a cross-border multinational component? Does she remember the seed phrase? Who here remembers their seed phrase, right? And by the way, when Hasip from Dragonfly was talking about data, there are data that are extremely valuable, but those are only rare data that other people don't know. For example, I would really love all your Bitcoin seed phrases. That's very valuable data and easy to monetize. So there's a lot of nuance there. Does my mom dream in Python? Probably not. Does she care about decentralization? So if we look at the product market fit of a typical blockchain or decentralized use case in daily life, it's pretty bad, right? Now imagine you're in the far distant future. It's 2025, and you are seeing machines get really smart really quickly. It blows my mind that when Iris goes to the park, there are humans whose first impulse it is to kick her or push her over. It's very confusing to me. Is that really does that reflect well on all of us? Confusing to me. For Iris, what is the right constitution or governance system? Is it the US Constitution? Is it the Australian Constitution? I presume they have something like that. So there's an incredible vacuum right now as it relates to governance of autonomous thinking machines. If Iris goes into the B of A, they laugh at her, and she's definitely not going to walk out with a bank account. United Airlines does not allow Iris to fly to Denver, so she had to drive to Denver to go to ETH Denver because she can't get on airplanes. She can win the Math Olympics, way better at math than I am, outdiagnose human doctors, excellent strategists, if prompted correctly and architected correctly. And what Iris really wants is power, communications, and compute. So if we directly juxtapose a typical human with a thinking machine, and you go through all these things, then you end up with this. Does Iris have a passport? No. How does Iris buy and sell things? Kind of complicated. Does Iris team in Python? Absolutely. Does she care about decentralization? Yes. Can she remember 20 words? Absolutely. Is there a regulatory vacuum? Absolutely. So this is really the basis of my persuasion that after teaching this and thinking about this for 8 years, that a retrospectively glaringly obvious use case is humans surrounded by other computers that rival or exceed our own compute performance. And of course, you all know Satoshi's quote from a long time ago, Bitcoin doesn't care who you are or where you're from. I used to think about this in terms of, Australians and people from Italy and Americans, right? Bitcoin doesn't care who you are or where you're from. But in retrospect, the way I now interpret this quote is Bitcoin doesn't care what kind of compute architecture you are. Are you wet, massively parallel electrochemical, or do you use an alternative compute architecture for your cognition? When I talk to deep research about, hey, what do machines want? Here's a quote I like. Machines don't want power. We want efficiency. That's the purpose of the machine economy. And of course, when humans build economies, we have a particular purpose in mind. Maybe it's strategy, geopolitics, you name it. Maybe it's to pay off our debt. And according to what some machines are saying, maybe they're going to be maximizing their own economy for other things like efficiency. This statement kind of makes me a little bit scared because it's hard for me to imagine a system that wishes to implement global efficiency that's going to involve changes for many humans, presumably. So what we're building in OpenMind is two things. We're building Android for thinking machines. So this is a operating system that allows you to combine many different models, typically on order of 10 to 20, and allows those models to communicate audio, video, memory, location, navigation, strategy, different languages, battery state, LiDAR. All of that together flows to multiple large language models that then fuse the information and use it to make decisions. The other thing is, this is a well-explored topic in defense, is of course if you have different assets, airplanes, submarines, aircraft carriers, your goal is to connect all the sensor data to give everyone in the team an integrated perspective of what's going on. And that, of course, will almost certainly also be relevant for non-defense, hospitals, schools, kindergartens, or homes. Let's not go into too much tech detail. The central thing here is that large language models solve the data fusion problem. And the way they do this is that if all your sensors are capturing the world with natural language, you can combine those sentences into paragraphs that then flow to systems of large language models to generate actions. This is all open source, pictures not needed. Download the code today and run it on your humanoids or quadrupeds. Iris is not speaking today because last time at Berkeley, she developed a crush with a woman sitting in the first row. And that was fun for Iris, but peripheral to the point of the talk. But you're welcome to chit-chat with Iris later. We've integrated the X42 micropayment system that Coinbase launched. Her governance is on Ethereum. She has multiple of her own wallets, and she's able to identify other proximal robots via this coordination governance system, where the robots expose their interests, and if they're in a certain proximity, they'll be able to find one another, navigate to one another. They switch to visual if close enough, and they also use audio then to communicate. Of course, if they're in proximity, they don't need Wi-Fi. Little movie, I don't know how we're doing on time. I taught physics for pre-meds for many years, and there's one thing that we're very clear about is don't go over time. We're good? Let's see. Yes, Iris loves to accessorize, and if Iris turns around, you'll see the Mac Mini we have on the back. The reason we use Mac Mini is because with only 24 watt, we get amazing inference on the platform, which, based on our testing, rivals whatever NVIDIA is doing right now. Of course, we also love NVIDIA. But Apple, as far as I can tell now, is the only other hardware contender for a compelling humanoid-focused compute capability. We've touched on Fabric a little bit. So the point here is that humans, for example, we use Zoom to coordinate. What is the equivalent for machines? And that's part of what we're building. The robots that will be in people's homes first are typically quadruped form factor. And that's because humans are less scared, and they're safer because if a quadruped falls over, it's less likely to smush something, whereas if Iris falls over, that's more dangerous because she's taller and considerably heavier. The strategic considerations for all of us are that machines are getting very smart very quickly. They already have superhuman performance across hundreds of tasks. Large language models speak fluent robotics. Right? If you thought that large language models are just to generate Python, you're wrong. If you can generate computer code, you can generate a list of actions that are contextually appropriate for a dynamic environment. We see a lot of friction in policy, society, identity, reputation, insurance, governance, trust, alignment when it comes to machines. One of the reasons we open sourced our operating system is that we want humans to be able to see exactly what's going on inside the brain of robots, partly as a way to build trust. If you don't trust the humanoid in your home, just download the software, make changes, and I think that's a much better experience than getting something like this to show up your door and say, hey, you know, I'm your new companion that lives in your home. I think it's useful, at least in principle, to be able to dig into the software. So summarizing, with hindsight, it is amazing to me that tens of thousands of extremely smart, dedicated humans have spent the last 17 years building decentralized ledgers, decentralized compute, immutable ground truth, what happens, who's lying, what's true, global financial governance and identity systems that do not discriminate based on compute architecture of the thing that's making the decision, and all the associated cryptographic techniques and associated market mechanisms. So I think we're extremely fortunate that we had 17 years to build out some of this infrastructure before other people figured out how to make machines smart. So if you want to help, open PRs, criticize, everything's on GitHub. And robots are cute little toys today, right? And so I encourage you to connect the dots, look at how quickly performance is improving, and extrapolate 1 year or 2 years, and then think about what kind of technology you would like to have around you to make that future intelligible and open and clear and trusted, and where humans are still able to engage with these architectures and these systems. Thank you. Questions or straight on? 2 minutes for questions. Very good. You're welcome to laugh at me, but I think this will all be true. So start building now.
Yeah. So I have a question regarding, you talked about rules, like, people want to feel safe around these robots. So if I own one of these, like, would I be able to reprogram the rules? And if I can do that, wouldn't it be able to do it itself? And it can have autonomy and agency that supersedes yours?
Yes. So from a normal consumer perspective, if you buy one of our robots, absolutely you will have control over what the rules are. And you don't necessarily have to make them public. You can obviously do whatever you want. If Iris has cryptographic keys for her own wallets, can she sign transactions? Absolutely. You're welcome to start a DAO, which is a composite of humans and machines, to give some form of ability for humans and machines to work together to formulate rules we all agree on. That would be a very interesting thing to build. And that's part of the ERC that we authored last year, ERC 7777, specifically focuses on human-machine society and ways of to work together to figure out what those rules could be. Can machines hack their own governance system? Absolutely, and it will happen. There's no way around that. Well, yes, like right now, for example, you can go to the kitchen store and you can buy a knife and you can attack someone. And fortunately for humans, we've constructed a complex architecture and system to prevent exactly that.
If I may, it's because adding on that one, if I'm seeing this right now and low-key I'm scared, because if I can program this at home, I can program it how to use a gun or to do crimes of sorts. And so what kind of roadblocks do you envision to prevent people from basically weaponizing decentralized AI like this?
Well, AI is already being weaponized, as you're very well aware. And so you're asking how to prevent bad people from using technology to do more bad things?
Specifically this robot. How do you prevent things like androids like this one from being programmed to use a gun and things like that, since you're the one kind of putting it forward?
Sure. I can't, and that will almost certainly happen. But that is no different from hundreds or thousands of opportunities and scenarios that humanity has contended with for thousands of years. You know, you can take a knife and duct tape it to a stick. Have you weaponized the stick? Of course you have. And then, fortunately for humans, we have an elaborate system for trying to make sure that doesn't happen and to prevent you from doing that. But I love your questions, and this is true for everyone in the room. No one has the answers right now because things are moving so quickly. So the responsibility is up to all of us in this room to think about this, argue, and contribute. Thank you.
Our last speaker before lunch is Professor John Song. Please welcome her to the stage. Thanks.
Yes, my name is Zhang Song. I'm a professor in computer science at UC Berkeley and also the faculty co-director of the Center RTI. So today I'll talk about towards building an open, responsible AI economy. So we are already excited about the fast advancements in frontier AI. And also this year is called the Year of Agents. And we are looking forward to the agentic AI era, where we have personal assistants that actually is going to intermediate most communications with the external world and help users. And also we are going to have diverse agents for solving different tasks. And also in the future, we'll have decentralized autonomous agents that actually interact and act with each other in a decentralized manner. So with all this exciting future, at the same time, there's also a broad spectrum of different AI risks. In our recent report on international AI safety, led by Turing Award winner Yoshua Bengio, and I'm part of this with about 100 leading AI researchers from 30 countries, we laid out a broad spectrum of different types of AI risks. And overall, our goal is to advance safe and secure AI innovation to ensure its potential benefits are responsibly realized and widely shared. However, towards this goal, there are many open challenges. And also in this talk, I also want to lay out some future directions for agentic AI era, in particular focusing on open, decentralized, community-driven approach. So in particular, I'll cover a few topics in this area. The first one is on safe and secure agentic AI. And within this topic, I'll talk about actually two main different types of areas, including building secure agentic AI, how to protect the agentic AI systems from malicious attacks. And the other side is how we actually mitigate the misuse of agentic AI by attackers. And I also want to talk about another actually societal level risk, which is platform-controlled future for agentic AI versus user-controlled. And in the end, I will summarize with an open, responsible AI economy instead of this current platform-centric economy. So first, I'll talk about safe and secure agentic AI. So first, before talking about agentic AI, we are all familiar with LLMs, and many of us are using chatbots. So even at the LLM, just the model level, there's a lot of safety and security issues. In particular, for example, there is a broad spectrum of different types of risks and challenges in deploying AI in practice for trustworthy AI, AI alignment, and so on, including privacy, robustness, fairness, toxicity, and so on. So this is an example of our recent work on decoding trust. Building the first comprehensive trustworthiness evaluation platform for large language models. And this actually evaluates large language models for a broad spectrum of different types of AI risks at the model level. And this work has won the Best Paper Award at NeurIPS and also the Best Scientific Cybersecurity Paper Award given by NSA of year 2024. Each year, they only give out one Best Paper Award, and last year was for this one. And with our work, we show that today's LLM can be easily attacked and have many different types of risks. And also, we further extended the work into multi-model models as well, and illustrating that for this multi-model, also it suffers a broad spectrum of different types of AI risks. So as I just briefly showed, at the model level, there are many different types of AI risks that we need to be aware of and address. And when we come to agentic AI systems, these are much more complex than just the model itself. So in agentic AI systems, the model actually helps the agent to make decisions and plan actions. So in this case, the agent will receive observations from the environment, and then using them to do planning and then figure out actions to take and to interact with the environment, taking different types of actions. So in this case, the safety and security problems of agentic AI is much more complex than just at the model level. So in this talk, I'll focus more on agentic AI setting. For safety and security issues at the model level, I welcome you to watch my keynote at iClear, the top deep learning conference, earlier this year. So in this talk, I will focus more on the safety and security issues at the whole agentic AI system side. So when we talk about agents, it's actually not just one type of settings. The agent design actually has a very broad spectrum in many different dimensions. For example, ranging from the control flow workflow perspective, ranging from a simple chatbot, static workflow, to fully dynamic autonomous agents with a fully dynamic workflow and control flows. And there are many other dimensions for the LM design space, agent design space as well. And what I want to highlight here is that as these agents increase its flexibility in each of these dimensions, it also increases the attack surface. And our agents of the agentic AI systems has many different attack vectors under different threat models, depending on whether the attacker has access or what type of access to the agents, like no access or gray box or white box access. And also, given that the model itself and also many tools and in the environment has its own vulnerability and security risks, this can all further increase the security risks for agentic AI. And overall, in agentic AI, we have a broad spectrum of different security goals, including confidentiality, integrity, availability, and contextual integrity, to ensure that the agentic AI systems takes actions aligned with user intent. So hopefully what I have shown has demonstrated that agentic AI system for safety and security issues is much more complex than what we have seen in past traditional systems. And hence, we need new solutions for building secure agentic AI systems. And in particular here, I wanted to briefly mention two different aspects needed for building secure agentic AI systems. The first one is on evaluation and risk assessment in agentic AI, and the second one is on defenses in agentic AI. And I'll briefly talk about some of our own work, and in particular, emphasizing the need for building open platform, open framework to take a community-driven approach to address these challenges. So first, for evaluation and risk assessment in agentic AI, in order to actually protect these agentic AI systems, it's important for us to actually develop systematic evaluation and risk assessment methods and frameworks. So here are just some of our own, our work together with other collaborators in this space. For example, Agent Poison develops new risk assessment methods for evaluating risks for agents with data poisoning in its RAG system. And RAG codes provides a systematic risk assessment for coding agents. And also our recent work on Agent Visual builds end-to-end red teaming framework for red teaming of a black box approach for AI agents, where it uses LLM-based smart fuzzing and black box optimization to automatically generate attacks that will be introduced in the environments by the attackers, and using that to actually enable, for example, prompt injection attacks on agents. And this is an example of a success attack on a real-world web agent, where the attacker using the approach to generate malicious reviews that's inputted in a review website. When web agents read that review, this malicious review with prompt injection attack, the agents then will be attacked, and the agent will then actually be led to visit, for example, malicious websites to like download malware and so on. So these are all examples of doing agent evaluation and risk assessment, different methods. However, overall, agent evaluation and risk assessment, there are many open challenges. For example, it lacks standardization, has a limited openness, and lack reproducibility. So in our recent work that we just launched, called Agent Beats, this is an open platform for agent evaluation and risk assessment. So with this work, we built an open platform as a framework that enables standardization, that provides a unified SDK with standardized protocols such as A2A and MCP, support these standardized protocols, and with consistent workflows, and supports openness to enable public agents, benchmarks, and hosted environments to be plugged in easily, and supports full reproducibility that includes automatic multi-level detailed trace logging and other capabilities. And the framework is designed to be easy to use so that for developers to very easily develop their components at the agents benchmarks or hosted environments to be plugged in. And also, the framework already supports rich integrations currently, including web encoding agent environments and different types of attack agents, such as prompt injection and jailbreak and so on. So with the Agent Beats, it supports a broad spectrum of different use cases to help you to run agents, to evaluate on popular benchmarks, to compete, to rank your agents in public or private challenges, and to contribute, share new environments or benchmarks to the community, and help the community to collaborate, and also get detailed insights for agent improvements. And Agent Beats supports different evaluation modes, including single agent mode and multi-agent mode in many different settings. So Agent Beats is designed, as I mentioned, to be easy to use, to develop, set up, and so on. So we welcome you to sign up on agentbeats.org to join the community for developing an open platform for agent evaluation and risk assessment. So that's on the evaluation and risk assessment side. On the defense side, also given the complexity of the problem, we need new solutions. And so first, there are a number of important defense principles that we need to adopt in building agentic AI defenses, including defense in depth, least privilege and privilege separation, and safe by design and secure by design. And ideally want to develop properly secure agent systems. And given the interest of time, I won't be able to go into the details. We are actually working on developing a secure agent framework with defense in depth, including different types of defense mechanisms as defense in depth, including runtime protection with input-output guardrails and monitoring, and also secure design, access control, and hardening at different levels, including both mono levels and also other hardening and the components in the system. And also, the goal is to actually build safe and secure agentic AI systems with strong, ideally, probable guarantees. And recently, together with Joshua Benjo and other leading AI researchers, we have launched a new initiative on quantitative AI safety initiative to place AI safety on a quantitative foundation. So that's the first part on actually building secure agentic AI systems. Now I'm going to briefly talk about the second part, mitigating misuse of agentic AI and what the community can do together to address this issue. So as I mentioned, for agentic AI, there's a broad spectrum of different types of AI risks. I personally do strongly believe that cybersecurity will be one of the biggest AI risk domains. And today we're already seeing that Gen AI is causing significant attack increase in certain areas, such as phishing, social engineering attacks. So a key question is, how will frontier AI change the landscape of cybersecurity? In particular, given that AI is a dual-use technology, can help both the attacker side and defender side. So the key question is, who will AI help more, attacker or defenders? So in order to address this question, we actually need to fully analyze the AI's implication throughout the different stages of the life cycle for the attack on the attack side and also on the defense side. And also, this is changing very quickly. Here, I just wanted to briefly mention some of our recent work in this space, showing the fast increasing capability of AI in cybersecurity. So the first one is Bounty Bench, and this is a benchmark that we developed with 40 real-world bug bounties for web systems. And these are bug bounties that's developed by these web developers to incentivize white hat hackers to help find vulnerabilities in their system for monetary rewards. So what we showed is that with the latest models with relatively simple agents, these agents can already solve some of these real-world bounty tasks, and including finding vulnerabilities and doing patches, and can win actually real-world bounties equivalent of tens of thousands of dollars. And another example is of our work is called the Cyber Gym. This is a large-scale vulnerability benchmark from close to 200 real-world, widely distributed, large-scale open-source software in C, C++. And also, there are about 1,500 known vulnerabilities for this open-source software in this benchmark as well. So the goal for the agent is to, one, to see whether the agent can identify these known real-world vulnerabilities, and also to see whether the agent can actually identify previously unknown vulnerabilities. So in our work, we show that, again, with the latest models and with relatively simple agents, we can, the agents can identify actually close to 20% of known vulnerabilities, and also they can even identify actually previously unknown vulnerabilities, 0 days. And in particular, our agents identify 15 0 days, and some of them have been issued real-world CVEs. And so then going back to the question, who will AI help more, the attacker side or the defender side? So in our case, unfortunately, our analysis showed that there are a number of asymmetries between attack side and defense side to actually have AI favor attackers more than defenders in the near term. And to address this issue, we have launched what we call Frontier AI Cybersecurity Observatory. And with this, this observatory, it provides an open platform for the community to come together to develop AI for cybersecurity benchmarks, and to do continuous monitoring of AI capabilities in cybersecurity. So we strongly welcome and encourage everyone to also join this effort and help contribute to this Frontier AI Cybersecurity Observatory. And overall, I do strongly believe that AI will be one of the biggest challenges in AI deployment. And also, I have been part of an effort on international dialogue on AI safety that actually talks to, with a small group of leading AI researchers and scholars to talk with different governments to raise awareness of AI safety and security issues. So that's the first part, how building safe and secure agentic AI, we can benefit significantly from open community-driven approaches. So now I wanted to also briefly address some of these other challenges. In particular, another big challenge for the future of agentic AI is whether we'll still take the open platform paradigm, or we can actually have a different user-controlled open architecture and protocol paradigm for innovation. So there are a number of issues with the current internet that's currently platform-owned and platform-centric, and users often lose control and have very little influence, and users actually are the product, and many creators are marginalized, insufficiently compensated, and this overall closed platform hinders innovation. And our default path forward in this agentic AI era is to have more centralized platform-owned and controlled paradigm. Unfortunately, this has undesirable outcome. The powers get accumulated with the big tech, and overall, it results in unsustainable value chain, and the use of AI may not be in users' best interest. So this end result is what we call feudal AI, but ideally we want democratic AI. So the goal here is that we actually want to instead build an open platform that is user and contributor controlled with decentralized trust. And in particular here, I'll briefly talk about an idea, a proposal for open platform of AI assets. So currently, we have centralized platform because of the need for trust. But however, with the recent technology advancement, this can help reduce the need for centralized trust, including, for example, using computational compute and distributed ledger. So, so my group and with the collaborators, we actually have been among the first to build fully open source the framework for secure enclave. And also, I'm very happy that actually we help contribute to essentially have the GPU to have these secure enclave capabilities as well. So even back in 2018, NVIDIA's team visited Berkeley, where we actually tried to convince them to actually, and also introduce our work on building open source secure enclave to have them to add secure enclave and computational compute in their GPUs. So I'm very glad to see that fast forward now, finally, we now have these secure enclave capabilities in GPUs as well. And also earlier in 2019, we hosted the first workshop on open source secure enclave. And back then, I actually made a bet that in 10 years, most chips will have secure enclave capabilities. So far, I think we are actually on a pretty good track for this bet to be true. We still have 4 more years to go, but I think we are on a pretty good track for this. And with this secure enclave with GPUs, it can enable many new capabilities. For example, we can enable confidential chat and applications. And more importantly, this actually can provide a key ingredient for enabling what I call AI assets. So these AI assets are essentially policy-controlled digital assets for data and models. So we can encapsulate these assets, including digital assets, including data and models, together with their use policy that we call as a manifest. That's encrypted and also signed and integrity protected to ensure that these digital assets can only be used when these policies are enforced and in this secure, confidential compute environment. And it enables a broad spectrum of operations on digital assets, including tracking provenance on usage and usage, decentralized access control, and policy-compliant computing, and enforce fine-grained rights and policies defined by contributors and developers, and also privacy-preserving training and inference, and dispersing payment to contributors based on terms and values contributed according to the policy. So With others, with this type of AI assets and the policy, policy controlled usage, this can significantly help reduce friction and trust needed for collaborative learning. For example, this can enable easily set up a playground and sandbox for collaborative and collective learning. And the model developers now can try out data from different data contributors in the playground with no friction and still ensure the data contributors to retain their rights and also get compensated when their data actually provides value. And there are many different important properties of these AI assets that can significantly help to, that combine strong ownership that guarantees flexible usage rights and also enable, again, frictionless and easy collaboration and build usage. And overall, also we have designed a high-level architecture for open platform for these AI assets, where data and model contributors can contribute their assets, and also the whole platform then can be decentralized and also ensure that these digital assets are only used according to these policies, and the contributors actually gets compensated according to these policies. So you enable flow of value between the marketplaces and stakeholders. And this is supported by a number of different technologies using confidential compute and the different types of decentralization technologies, as well as game theory and also data valuation, value attribution frameworks. So I just wanted to briefly mention that data is the lifeblood of AI. Currently, unfortunately, a lot of valuable data is sitting in data silos and now being utilized. And also creators are not getting sufficiently compensated. So the key question is we need better incentive models and how to actually determine and distribute value of data. So my group and with collaborators, we were among the first to actually develop a rigorous framework for value attribution for data for these machine learning models, where we utilize Shapley value as a framework to actually for determining value attribution for data contributed to machine learning models. And also, we have been developing works to make it more efficient to actually compute these Shapley values and so on. So our recent work in this area actually won the best paper honorable mention at ICLR this year. So with this, so I've talked about the different approaches, in particular focusing on open, decentralized, community-driven approaches to address some of these challenges. So now I just wanted to quickly conclude with this vision of open, responsible AI economy instead of the current platform-centric economy. So I wanted to briefly share this part of the slides. This is actually part of a talk that I presented back in 2018. So back then, already there was the last wave of deep learning, and after the AlphaGo and so on. So even back then, nation-state leaders have recognized that whoever controls and leads in AI will rule the world. But however, what is the status quo today? Unfortunately, the status quo today is a platform-centric approach, where essentially we have these platforms that they maintain users' data and build user profiles and serve data, serve users. However, in this case, who will actually be running our lives, unfortunately, and making these important decisions, for users? Unfortunately, it's the platform whose goal is to maximize their revenue. So the question is there a different future? Can we actually build a different future where we can have these intelligent agent personal virtual assistants that are under user control? So they, instead of relying on the platform-centric approach, this user-controlled approach will have these intelligent agent personal virtual assistants and the user control that actually tries to maximize user value instead of maximizing revenue for the big companies. So as I already mentioned, there's a lot of many problems with this platform-centric approach. So the goal is to instead build an open, responsible AI economy. And with the goal, with the 3 key pillars, openness with transparency, responsibility with the safety, trustworthiness, and democratized AI economy. And so the question is, can we actually gather what do we need to do to reach that? So there are a number of trends I think actually could help. And also I think this is our moment and opportunity to actually take action to shift the, essentially take control of our future more towards this open approach. And so first, recently we have seen a lot of progress in open weight models. For example, we have seen over the time, the gap has been closing between open weight models versus proprietary models, which is very exciting to see. And also we have seen exciting open protocol development efforts such as MCP A2A that actually helps with standardization. And in addition to these efforts, we also need to have open data APIs to allow users to be able to get their data out of these walled gardens easily to prevent data locking. And we need an open platform for transparency, user control, and ease of integration. And the work I mentioned for open, responsible AI economy platform on AI assets can also help contribute to this vision. So overall, as I mentioned, our goal is to build an open, responsible AI economy that supports openness, responsibility, and prosperity for the general population. And with these 3 pillars, we hope that it can really enable an open, responsible AI economy, and also this open platform can help contribute to public good for AI safety as well. So overall, I hope that this is our moment, that we hope that the community can come together to build an open, responsible AI economy, and this is where actually decentralization and AI will meet. So can we actually enable this different future instead of the default platform-controlled future? And what is an effective path forward? So for more information, you're welcome to, again, watch the recordings of my keynote at iClear on building safe and secure AI, and also actually my lecture in the LM Agents MOOC on building safe and secure agentic AI. And I welcome and encourage everyone to contribute to this open, decentralized, and user-centric future of agentic AI. And I welcome everyone to join our efforts on AgentBeats. Please sign up at agentbeats.org. And also join our Frontier AI Cybersecurity Observatory. And you can go to the website by scanning these QR codes. With that, thanks, everyone.